This video is for day 5, which is Monday, March 30th, the first day of our second week. I figured after last week we should go back maybe and try to review simplifying radicals. Before I do that, you remember this that we did up to 15. You have your numbers 1, 2, 3, 4, 5, 6, 7, keep going up. Our perfect squares, so 1 squared is 1, 2 squared is 4, 3 squared is 9, so forth and so forth. Perfect cube, 1 cube is 1, 2 cubes 8, 3 cubes 27, so forth and so on. And our perfect fours, 2 to the 4th is 16, 3 to the 4th is 81. So these numbers you should have memorized before. If they're gone, try and get them back. Doing some simple radical simplification, if I'm asked to simplify the square root of 32, 32 is the same as 16 times 2. What we're asked to do is have this radicand not contain any factor that's a perfect square. So that's the square root of 16 times the square root of 2, which is the square root of 16 times the square root of 2, which is 4 times the square root of 2. It works nice with numbers, and it's much easier with variables. The square root of 4xy squared, well, of course, the square root of 4 is 2. X has no perfect squares in it, so that's just going to be an x in here. And y squared is a perfect square, so the square root of y squared is y. Basically, the index here is 2. With the variables, we take the 2 and see if it goes into the exponent. 2 does not go into 1, so no x's can come out. 2 goes into 2 one time, so 1y comes out with no y's left over. Basically, all I'm saying is the square root of x to the 4th, y to the 5th. Long and drawn out process, I'm going to show you the shortcut. 2 goes into 4 2 times, so 2 x's come out. There is no remainder, so there's no x left inside. 2 goes into 5 2 times, so 2 y's come out, or y squared, with a remainder of 1, so there's 1 y in. What that would look like is x to the 4th can be rewritten as x squared, y to the 5th can be rewritten as y squared, y. Every perfect square is going to come out as a single x, a single x, a single y, and this y cannot come out. It's got a power of 1. So that's x squared, y squared, square root of y. So another example would be a square root of 54x squared, y cubed. You just got to find a perfect square that goes into 54. And if you look pretty hard, you're going to find 9 times 6. The 9 will come out as its square root of 3, leaving the 6 inside, because 6 contains no factors that are a perfect square. All right, x squared, it comes out as just x, and there are no x's left over to go inside. Y cubed, I can take 1 y out, and 1 y has to stay in. All right, cube roots. Little index of 3 there, cube root of 8. Well, we look up here. Oh, look, 8's a perfect cube. So the cube root of 8 is 2. Not that bad. Cube root of 54. Well, what perfect cube, so cubes right here, these values, I don't care about squares. Which one of these guys goes into 54? And you can see that it's 27. So that's going to equal the cube root of 27 times 2. Cube root of 27 is 3. Cube root of 2. And I can just do more problems like that. Cube root of 128. Well, are there any perfect cubes that go into 128? And there it is, 64 times 2. So this is 64 times 2. So this cube root of 64 is 4. Cube root of 2. So I hope that helps. Maybe it was a little confusing last week doing the rational exponents with the radicals, changing it and simplifying it without doing a review of radicals first. So my apologies for that. Hopefully this helps. That's all there is for Monday, the 30th of March. If you do have any questions, please don't hesitate to ask me on Google Classroom. I'll have another one up for you tomorrow that will go in a little more depth. Thank you. Have a great day.